There were a couple of errors in boardwork in this segment. The first error appears on this slide where I talked about how for damping of higher order modes we need to go a step beyond merely looking at unconditional stability. The inequalities that we are talking about in this case appear here, and the error is in this very last inequality. I wrote it as just gamma plus half the whole square. It should be gamma plus half the whole square divided by 4. Okay, that gives us the correct condition to be satisfied for damping of higher order modes. The next error appeared 2 slides later. There we go. And it appeared in the way I labeled that equation. I called it, as it appears there, the time exact modal equation. That is not quite correct. The equation I've written out there is obtained by substituting the time exact or the time continuous solution into the time discrete modal equation. Okay? When we do that, we discover that the time exact solution does not actually satisfy the time discrete modal equation. Instead, we're left with this extra term here, right? And it's on the basis of this term that we talk about consistency and accuracy of the method. So properly, this equation should be labeled just what I called it, which is the time exact solution substituted into the modal equation. Okay, so let me call it that, time exact solution, SOLN, short for solution, okay, substituted in time discrete modal equation. Okay, when we do that, we get this extra term like I reiterated a minute ago, and that is the basis for our analysis of consistency and accuracy of the method. With that, things work out consistently. I need to make a correction to this already corrected slide. If you look at the update formula at the very top of the slide, I inadvertently wrote y sub n plus 1 on the right-hand side, and that should just be y sub n. That's what makes it an update formula, right? So you go from something at n to n plus 1. So that should now read y at n plus 1 equals a multiplying y at n plus l at n. With that, everything should indeed work out.